Now we're going to look at this balancing act sheet, and we're going to go through how to actually balance a chemical equation so we have the same number of atoms on both sides of the arrow. So let's fill out this paragraph first with some terms that we need to know. And some of these things we'll be coming back to later, but these are kind of important concepts to understand chemical reactions. So atoms are not created or destroyed. During a chemical reaction. Scientists know that there must be the same number of atoms on each side of the equation. To balance the chemical equation, you must add coefficients in the front of the chemical formulas in the equation. You cannot add or subtract subscripts. Okay, so we're going to look at some steps of how to balance these equations. First, what we're going to do is determine the number of atoms for each element. We're going to use this lower part right here to help us keep track of what's going on in the chemical equation, which is up here. In this example, or these examples on this page, we'll have a box in front of the molecules or atoms. And in other examples, you may not see that box. That box is just to show us where a coefficient could go. So I'm going to draw a line separating the reactant side on the left from the product side on the right. Now what I'm going to look at is, let's count how many atoms I see of each element right here. So Mg, I just see no coefficient, no subscript or coefficient, so that means I have one of those, and O2 means I have two of those. On the right-hand side, it looks like I just have one of each, one and one. Okay. Now, how do we balance it out? Because I have two oxygens on the left, but only one on the right. The only thing I can do is, remember, I cannot add a subscript. You're not allowed to do that. So what I have to do is add a coefficient. So I'm going to put a coefficient of 2 there, and that now multiplies through the molecule. So that means I don't have 1 anymore right here of magnesium, I have 2. And for oxygens, now I have 2 oxygens. So it multiplies through both, and now I have 2 of each. Now if I compare, my oxygens look good. They are balanced. I have 2 on the left, 2 on the right, but my magnesiums are not balanced. So what I'll have to do on the left-hand side is now I'm going to have to add a coefficient of 2 in front of the Mg. Now 2 times 1 gives me 2. So now if you compare, I have 2 magnesiums on both sides and 2 oxygens on both sides. It is now balanced, and I'm done. Notice that I don't have a number in this box right here for oxygen. It's assumed to be 1, just like in algebra. You wouldn't write 1x or 1y. It's assumed to be 1, so you don't need to put that. Just like if you look at this Mg by itself, there's no subscript here. It's assumed to be 1. Let's move down and try another example following these steps. So let's look at this one. This is very similar to what we just did. I'm going to put, again, I'll put a line here to kind of separate the reactants on the left from the products on the right. I have Ca, there's 1 calcium, and I have 2 oxygens. Over here, I have 1 and 1. So now, what am I going to do? Well, same as we did last time, the oxygens are not balanced. I'll have to put a 2 here. So when I do that, that gives me 2 of each. Now I can see that the calciums are not balanced, so I'll have to adjust coefficient on the left. I'll put a 2 there. 2 times that calcium gives me 2. Now it is a balanced equation. I can stop there. I don't have to go any further. Okay, let's try this one. I hope you get it set up, and then I'd like you to try to figure it out. So here's our count on both sides. Think about what you would try, and use a pencil with an eraser to do these, because you may make mistakes as you do some trial and error to figure out the coefficients. So you can pause it right here, see if you can figure this one out, and then in about a minute or two, I'll walk you through it again. Okay, now you're back, and let's look at some things you can do here. If you try to balance the ends first, let's try to do that. I'm going to put a 2 here, and that means that this changes to 2, the nitrogen changes to 2, but the hydrogen would change to 6. 2 times 3 is 6. So now over here, what could I do? Well, I could multiply 3 times 2 gives me 6. Now if I compare, that works because I have 2 nitrogens on the left, 2 on the right. I have 6 hydrogens on the left, 6 on the right. I'm finished. That one's done. Okay, again, let's pause it right here, and I want you to try the last 2. This last one is a little tricky, so watch out for this one right here. Okay, now we're back, and what we want to look at is the answers to this. So I'm going to put down the counts here. I'm going to kind of go through these quickly, and then I'll have you try some on your own. So here's my counts to start. I'm just switching colors so you can see how I change them. So then I'm looking at, let's say I use the copper first, and I put a 2 here. Let's try that. Okay. Now I have to adjust the oxygens. Okay, so that means I guess I needed to try a 2 here. But when I put a 2 there, see what happens to the coppers. 2 times 2 is 4, so this becomes 4, and my oxygen becomes 2. So now my copper is off again. So what that means is I'll have to erase this coefficient, and I'm going to have to put a 4 in there to make it balanced. So the 2 was actually not enough. So now the 4 works. I'm almost done. Oh, I am done because look, the carbons are already balanced. So that one's done. Let's look at the last one here. Last one, I have 2 on this side, 2 on this side, 2 on this side. But be careful here. Oxygen's count is 3. 1 plus 2 is 3. This one's a little tricky. Here's how I would do this one. If you're stuck, just do some trial and error and see what works. So for example, if I put let's say I put a 2 here, okay, and that changes this to 6. Oh, I'm sorry, it changes it to 4. If I put a 2 there, it changes this to 4. What could I do to the other side? I could do a 2 here, and that will make this 4 and this 4. Now I take a look at it. Is that going to work? Well, maybe I have to put a 2 here, and that becomes 4, and then 2 oxygens plus 4 is 6. So that doesn't seem to work right there. So what I'm going to do is I'm going to go back, I'm going to erase, and I'm going to try something else. So this might happen to you where you try it, you might have to erase it. Again, don't push real hard with your pencil, do it lightly, and might be some trial and error involved. So I'll start over here, and let's do this 2. Okay, over here I have 2 and I have 3. So what can I do? Well, let's try. I tried a 2 here before. What if I put a 2 here? So let's try a 2 there. And that means that the hydrogen becomes 4. And then the oxygen would be 2 plus 2. That would be 4. All right. So when I do it that way, oh, if I put a 2 here, that makes this 4 and this 4. Because 2 times 2 is 4, 2 times 2 is 4. So that one looks tricky at first, but it's actually because you're adding the oxygens here that what makes it look a little tricky. It's actually a very simple solution. Okay, so that finishes this page. What I would like you to try to do is try some on the next page, and I'll be putting together a video for that part. But in the meantime, see if you can try adding those coefficients and doing some counting for those.